In this tutorial, we will be discussing stoichiometry. In the process, we'll also be discussing stoichiometric ratios. Coefficients in a chemical reaction specify the relative amounts of moles of each of the substances involved in the reaction. We've done this by balancing the chemical reaction. These numbers in front are the stoichiometric ratios. It's a numerical relationship between the chemical amounts in a balanced chemical equation. Think of it as a recipe for chocolate chip cookies. You need 2 1/4 cups of flour, 3/4 cup of brown sugar, 2 cups of chocolate chips, and so on to make 50 cookies. Well, if you don't have enough brown sugar, then you have to reduce everything else so that way you can make cookies. Or if you need twice as many, if you need 100 cookies, you need to double everything. So it's always the same ratio. Think of the recipe as a chemical reaction as a guide. If you have different amounts, other amounts need to be balanced out. When we deal with the numbers in front, when we deal with the coefficients, they represent moles. You need to use moles. So if you're starting with grams or if you're starting with molecules, you need to get it to moles before you can actually relate it within the chemical equation. So if we were to break this chemical reaction down, it would say for every 1 mole of tin that's formed, there's an invisible 1 here. You'll need 1 mole of tin 4 oxide and 2 moles of hydrogen gas. You use the coefficients to calculate the amount of one substance from the amount of another. So for instance, if we are trying to figure out how many moles of H2O, I always put what we're looking for right underneath the actual part of the chemical equation, so that way I have a visual. Can be produced from 4.7 moles of tin oxide. Notice it's giving us information about one thing, but it's asking us about something else. So we're going to relate those two by using the coefficients. And then once you figure out how to relate the two, once you figure out how to convert, this will be a conversion factor. So for every 1 mole of SnO2, we can make 2 moles of water. We then put this into our dimensional analysis equation. Put the number we're starting with over 1, so 4.7 moles of SnO2. If you have yet to do so, make sure you actually write down what compound you're talking about, because if you don't, you're going to be confused because we're switching compounds in this process. We have moles of SnO2 on the top. We want to put this on the bottom of the next one. We are right here and we're using the coefficients. There's no number there, so that's automatically a 1. And we're looking for water, which is a 2 moles of H2O. Notice that the moles of SnO2 cancel each other out. So it's 4.7 times 2 divided by 1, and that comes out to be 5.4 moles of H2O. Remember, whatever's on the top of your last line is what your units are going to be. Let's try another one. If we have 2 moles of N2, so 2.00 moles, reacting with sufficient H2, that just basically means we have enough that we can let it go all the way. How many moles of NH3 are going to be produced? We're going from moles of N2 to moles of NH3. Notice we have a horizontal line here. We're going from one compound to another. Whenever you have a horizontal line, you're going to be using coefficients. Alright, now we know what to use, so we can put it into our dimensional analysis. 2.00 moles of N2 goes over 1. Moles of N2 are on the top, so I'm going to put that on the bottom of the next one. The coefficient for N2 is 1. where we're going to, what they're asking about is NH3. So moles NH3, and there's a 2 in front of that, so that's going to be the number on top. So 2.00 times 2 divided by 1 is equal to 4.00 moles. Notice that there are 3 significant figures here, so I want to have 3 in the answer. Okay, we're just going to keep going and do more practice. 6 moles of H2 this time. How many moles of ammonia? Once again, we're going from one compound to another. We have that horizontal line there, which means we're going to use coefficients. So 6.00 moles of H2 over 1. We have moles of H2 on the top, which means we want to put moles of H2 on the bottom. Now we look at the coefficients because we're going from moles of one thing to moles of another. And that number is 3. On the top, we have 2 moles of NH3. That's what we were looking for, moles of NH3. So 6 times 2 divided by 3 comes out to be 4.00 moles of NH3. We've been going from left to right. We've been going from the reactants to the products. You can actually go from the products to the reactants as well. Let's say we want to make 2.75 moles of NH3, and we want to know how many moles of N2 we need. So we can make the arrow go the other way as well. And we're still going to use coefficients. Whenever that line is horizontal, we want to use coefficients. So 2.75 moles of NH3 goes over 1. Moles of NH3 on top, so I want to put moles of NH3 on the bottom. We're going from moles of one thing to moles of another, so we're going to use the coefficients. We're going to N2, so that's 1 mole of N2 because that's the coefficient of N2. So 2.75 times 1 divided by 2 comes out to be 1.38 moles of N2. Let's get a little bit more difficult here. Let's start talking about grams and using the molar mass with it as well. So this time, how many grams of chlorine can be liberated from the decomposition of gold 3 chloride, 64.0 grams? Alright, so we're going from one thing to another thing. We're going from one compound to another. We still need to get the coefficients to do that. But in order to use the coefficients are in moles. Moles are always the end caps to that horizontal line. So we need to get from grams to moles in order to be able to do that. In order to do that, we need the molar mass. So we have 1 gold, and we have 3 chlorines. The mass of gold is 196.97. So 1 times that number is 196.97. Chlorine is 35.45. You find these on the periodic table. That comes out to be 106.35. Add those numbers together for a grand total of 303.32 grams is equal to 1 mole. And that's for gold chloride, gold 3 chloride. Now we're in moles, and we go from moles of one to moles of another using coefficients. The question is actually asking about chlorine, about the mass of chlorine. So that means, once again, we need to use the periodic table because it's asking for grams. So 2 times 35.45 is equal to 70.90 grams is equal to 1 mole. Alright, so 64.0 grams. We have all our conversion factors, so we can go ahead and put this over 1. AuCl3 grams on top, so we're going to put grams of AuCl3 on the bottom. We calculated that number out from the periodic table of 303.32. and that is 1 mole of AuCl3. Notice that even though it's a coefficient of 2, when I use the molar mass, I only put a 1. This is the mass of only 1 mole. We use the coefficients when we use the horizontal line, and that's the only time you ever use the coefficients. So we have moles of AuCl3 on the top. I want to put moles of AuCl3 on the bottom, and that coefficient is 2. On the top, we have is where we're going to, and that's 3 moles of Cl2. Now the question is actually asking us for grams, so we need one more. 1 mole of Cl2 is 70.90 grams of Cl2. And remember, we got that off the periodic table. So, to put in the calculator, we have 64.0 divided by 303.32 times 3 divided by 2 times 70.90, and that comes out to be 22.4 grams Cl2. Let's try another one similar to that. Calculate the mass of AgCl2 or AgCl that can be prepared from 200 grams of aluminum chloride. Notice this decimal here, or that means that those zeros do count, so there's 3 significant figures here. That's the reason why they put the decimal. Alright, so we're going from one compound to another, which means we're going to need a horizontal line. The moles are the end caps to the horizontal line. We're going to use coefficients for that. Grams to moles in order to be able to get to the coefficients. So we have aluminum and we have chlorine. We have 1 aluminum and 3 chlorine. 26.98 and 35.45. 106.35. Add those together for 133.33 grams is equal to 1 mole of AlCl3. Now, we use the coefficients to get moles of AgCl, and we're going to use the, you notice that it says grams, so that means we need molar mass again, which means we need the periodic table, Ag and Cl, 1 times 107.87, and 1 times 35.45. We're going to add those together to equal 143.22 grams is equal to 1 mole. Alright, so let's put our number over 1 now that we have all our conversion factors. 200 grams of AlCl3 over 1. All we did was turn it into a fraction. We need grams of AlCl3 on the bottom, and that is 133.33, 1 mole AlCl3. The next line, we need moles of AlCl3. And then we look at the coefficients, because we are right here in our plan. It's 1. And we're going here to moles of AgCl. And that coefficient is 3. Then 1 mole of AgCl is 143.32 grams. Alright, 200 divided by 133.33 times 3 times 143.32 all equals out to be 645 grams of AgCl. Notice there's 3 significant figures because the question itself had 3 significant figures. Alright, let's do a mass to mass one more time. 30.0 grams of Ki. We're looking for the mass of PbI2. So, we need to go from one compound to another, and moles are the end caps. To get from one to another, we need coefficients. So we need to get from grams to moles of Ki. K is, these two things combined is 166 grams is equal to 1 mole. We got that off we added those two numbers to from the periodic table. These two things combined, 1 Pb and 2 iodine, combined is 461 grams is equal to 1 mole. Because it's actually asking for grams, which means we need that from the periodic table. Alright, so now we have all the conversion factors. We can put our number over 1. 30.0 grams of Ki. We have grams of Ki on the top, so we're going to put grams of Ki on the bottom of the next one. We calculated it 166. That's from the periodic table. 1 mole of Ki. Now we have moles of Ki, which means we want moles of Ki on the bottom. Coefficient is 2. We're going to PBI. PBI 2, and there's a coefficient of 1. Now it's asking for the mass, so 1 mole of PBI 2 is 461 grams. So we put in our calculator, 30 divided by 166 divided by 2 times 461. That comes out to be 41.7 grams PBI2. Alright, on these last two, we're going to switch it up a little bit. It's actually asking for molecules now. From 64.0 grams of this, we're going from one compound to another. The method is going to be the same. Moles are the end caps. Use coefficients to get from moles of one to moles of the other. So to get from grams to moles, we need to figure out the molar mass. 1 times 196.97, 3 times 35.45, that comes out to be 303.32 grams, 1 mole. Now, we go from moles to moles using the coefficients, and then moles to molecules. That's one of the 4 key terms for Avogadro's number. Alright, now that we have all our conversion factors, we can actually put the number, over 1. 64.0 grams of AuCl3. We need grams on top, so we need to put grams on the bottom of the next one. 1 mole AuCl3 goes on top. We are right here in our plan. We need to go from moles of one to moles of another. So 2 moles AuCl3 yields 3 moles Cl2. Then 1 mole Cl2, we're looking for molecules this time. 6.022 times 10 to the 23rd molecules. Now remember, you don't put times 10 into the calculator. That's your EE button. So 64 divided by 303.32 times 3 divided by 2 times 6.022 EE23, 1.91 times 10 to the 23rd molecules. We're going to do one more in this tutorial. Calculate the number of formula units of AgCl that can be prepared from 200 grams, notice the decimal again, of AlCl3. We're going from one compound to another. Moles are the end caps. So to get to moles, we need to figure out the molar mass of AlCl3, which we have in the past in previous slides. So 133.33 grams is 1 mole. Moles to formula units is 6.022. Formula units is one of the key terms for Avogadro's number. Atoms, ions, molecules, and formula units are the 4 words you look for the 6.022 number. Now that we have all of the conversion factors we need, we can now put our starting number over 1. We have grams of AlCl3 on the top. We want to put grams of AlCl3 on the bottom of the next one, and then put the molar mass with it, and that's equal to 1 mole of AlCl3. Now we are right here in our plan. We're going from moles of one to moles of the other. Therefore, we're going to use coefficients. 1 mole of AlCl3 is 3 moles of AgCl. One more bracket. We're right here, and we want to get to formula units. So mole of AgCl, 1 mole of AgCl is equivalent to 6.022 times 10 to the 23rd formula units. So 200 divided by 133.33 times 3 times 6.022 EE23, and it comes out to be 2.71 times 10 to the 24th formula units. And that gives you an explanation on how to complete stoichiometry problems.